Alright, so this second one is all dedicated to equations. And being that a lot of you have to retake the quiz, this is going to be a perfect video for you, and it's also going to be the shorter video. Alright, so 25 was the first one. 25 is a log. Remember, there were 4 different types of things that you should have reviewed for that last quiz. So this is the type where we have to go from log to exponential. How do I know that? Because I don't have 2 logs on both sides. So I'm going to have to go from log to exponential. Again, I tell you to memorize this. If you can't memorize it, then if you can memorize it for 2 seconds and write that at the top of your test, then it will help a lot. Alright, the first thing I need to do is isolate the log. So I need to get this ln by itself. So to do that, I'm going to divide. I need to get rid of this 2 that's standing in front of there. So right now I have ln x equals 2. Remember, ln is the same thing as log base e. So what I need to do is rewrite this as log base e. This is not the answer to the question. This is just a rewrite. So since I rewrote it, now I'm going to go from log to exponential. Now I'm going to do this. So I rewrite it as e to the second power equals x. And technically, that's my answer. But if I wanted to take it one step further, I would put it into my calculator by doing second ln squared. And I get 7.389. And that's it. Alright, 26 is the double log because you have 2 logs on each side. This is the one that needs a check because you have to check for negative logs. So no, you do not have to do this down here. So we're going to cancel out these sides and just set them equal to each other. You should always get rid of the smaller variable, so I like to get rid of the negatives before the positives. So if you do 12 divided by 8, you get 1.5. So you are allowed to get decimals. You're just not allowed to get negative logs. So now we should check it just to make sure. So 3 times 1.5 is 4.5, and 4.5 minus 4 is 0.5. And negative 3 times 1.5 is negative 4.5. Alright, I don't know why I wrote 3 here. It's a 5. Okay, so negative 5 times 1.5 is negative 7.5 plus 0.8. Plus 8 is 0.5. There you have it. It is fine because both of these are positive. Decimals are okay, so this is okay. Phew. Alright, next one is going to be the same base rule. So you have to make sure you get the same base here. They're not the same. I do know, looking at the problem, that I can get 2 because 2 to the 1 is 2 and 2 to the negative 1 would be 1 over 2, so I can use 2. So I've changed 1/2. I no longer have 1/2, and I've changed it to 2 to the negative 1, leaving 2x minus 6 on the outside. 16 is 2 to the 4th. I've gotten rid of that. and I'll leave the x on the outside. Next thing I want to do is set my exponents equal to each other. I no longer need my bases because I have the same base. So make sure you distribute. Distribute. So negative 1 times 2 is negative 2. Negative 1 times negative 6 is positive 6. 4 times x is 4x. So for balance purposes, you add 2x on both sides. 6 is equal to 6x. Divide by 6. X equals 1. Alright, next one is an exponential. So you're actually going to go from exponential to log. So you're going to be using this one but working backwards. So the e is already isolated, there's nothing around, so I'm going to go right to this. Log base e, because that base stays the same, and then I'm going to take the 124, put it next to the e, and took the 3x and put on the outside. Now remember I told you that log e is the same thing as ln. So I'm going to rewrite this now as ln of 124. Okay, that's a 1, that's a L. Equals 3x. I didn't solve for anything, I just rewrote. I got rid of that and made it ln. So now divide by 3, so x is equal to ln of 124 over 3. Now I can get the actual answer by pressing ln 124 close parentheses over 3. And that's 1.607. Alright, 28 and 29 are exactly the same, except one has base e, one has base 10. But they're the same problem. So it is another exponential to log problem. So I'm going to go right to this. I don't need to isolate. So I'm going to write log base 10. The 23 goes next to the 10 now. And 4x. Divide both sides by 4 because I'm done. And my answer will be log base 10, which I don't need anymore because your calculator recognizes the base 10, over 4. Now if you leave a base 10, that's fine. Just don't put the base 10 in your calculator. So, to get our answer, we're going to do log of 23, close parentheses, over 4. And you get 0.340. Please write the decimal answer and the regular answer. Okay, this is the regular, this is the decimal. Alright, we have one more in this section. And that is the another double log problem. So this is double logs. You know, when you have double logs, you can just cancel them out and just solve what you have. Like I said, I like to get rid of the smaller variable first. So I have negative 3. Now normally when I get a negative answer, I get a little worried because in the past all of our negative answers have given us negative logs. But you still have to check for that. So when you check, you're going to do log of 2 times negative 3 plus 7 should be equal to log of negative 3 times negative 3 minus 8. So when you put this in your calculator, you get 2 times negative 3 plus 7. That's only 1. And then negative 3 times negative 3 plus 8. Oops, minus 8. That's 1 as well. So we have log of 1 equals log of 1, which is allowed. So this is okay. Alright, so you see a lot of different colors going on, but the main thing that you should pay attention to is how do I solve it. So pay attention to these little rules here, because they'll allow for you to differentiate what rule to use when. Shh. Let's see if you can find out this answer. Alright, last few questions and then that's it. So here was number 31. A lot of you asked me to do 31. 31 actually winds up being an exponential to log question. Okay, so remember, and I'll write it on the side here, how to go from exponential to log. Alright, first thing we need to do is isolate the e. We need it by itself, so we're going to divide by 12. So you're left with e to the 3x minus 2 equals 8 over 12, which is really 2/3, but you don't really have to change it. So now we're going to go from exponential to log. So the first thing I do is I write the word log. And I bring the same base down. The 8/12 winds up going next to log. And 3x minus 2 goes on the other side. Now I need to solve for x. So I first start with adding 2 on both sides. Notice how these are separate from each other. Now my last step will be to divide by 3. So my answer to this question is log base e, 8 over 12 plus 2 over 3. Now you know your calculator does not have log base e, so you have to change this log base e to ln. So in your calculator, you're going to put ln 8 over 12 close parentheses plus 2, enter, and then divide it by 3. Because if you try to put it all together, it's going to come out crazy. Alright? So 0.532 is the answer. Alright, the next one is same base. And the great thing about this problem is that it already has the same base. You don't have to find anything, so you can just cancel out the bases and solve for x. If you see a problem like this, you should be happy because you just have to solve for x without doing anything to the bases. There you go. Alright, the next one says log of 4x. That is an example of log to exponential, which is right here. Now, it's already isolated. The 4x is actually part of the log, so you don't have to do anything. The only thing you have to do is change it First thing you should do is put that imaginary base of 10 so you know what base to make it for here. So I'm going to go 10 to the third power equals 4x. So always just switch these two around. So that's why I always do this arrow to show you that 10 is going to have that power. 10 to the third is 1,000. Divide that by 4. X equals 250. Okay, the next one is also log to exponential, but you have to isolate your log in a different way. Instead of dividing, you're actually going to subtract because that has a plus here, which means that you have to do the opposite of 7, which is negative 7. So log of x equals negative 3. Again, place the imaginary base of 10 there so that you can rewrite it as 10 to the power of 3, or negative 3 I should say, equals x. That's your answer, but you know you want to take it one step further, and your calculator just say that 10 to the negative 3 is 0.001. I don't know why they didn't change it to 1 over 1,000, because that's the real answer, but I will take that as well. Alright, we're almost done. Okay, the 35 is also log to exponential, but you have to isolate this problem twice. First thing you want to do is get rid of the 3 by adding, and you get 2 ln x equals 8. Divide by 2, you get ln x equals 4. Remember what I told you a long time ago. I said ln x is the same thing as log base e. So you have to change that as e. Now by doing that, that helps you see that you're going to change it from log to exponential. E becomes your base. The y that was here becomes your exponent, so the 4 becomes your exponent. And then x would be your answer. So that means e to the 4 equals x. And that answer is 54.598. Whew. Almost done. We got like 5 more problems. Alright, next we have 36. This is a double log problem. So you're going to do 9x minus 1 equals 4x minus 16. Minus 4x on both sides. Add 1. X equals negative 3. Again, you have to check these because you can't have negative logs, so you're just going to place that negative 3 in for x. So it's 9 times negative 3 minus 1 equals 4 times negative 3 minus 16. So 9 times negative 3 minus 1 is negative 28. Uh-oh. And then we do 4 times negative 3 minus 16. Uh-oh. Another negative. Well, since these both came out negative, you know you're not supposed to have negative logs at all. So you should cross these out, cross that out. Make sure you cross both of them out because you're not allowed to have negative logs, which means this answer does not exist. And you have to write no real solution. You would never know if there was no real solution if you never checked it. So make sure all the double logs get checked. Alright, so on this page we had exponential to log. We had same base. We had log to exponential, double log, log to exponential, and log to exponential. So a lot of different examples, and we had our first no real solution. Alright, 2 more equations. I thought there were 3. So this one here is called exponential to log. So what I'm going to do is first isolate by getting rid of the 3. And now I have 10 to the x equals 17. Remember the rule says okay, these are supposed to be double arrows. Oh, here's the arrow. That's a double arrow, not an equal. Whew, tired. So you have 10 to the x equals 17. So here's your 10x 17. So you write log base 10. 17 now goes next to the base, and x goes on the end. So we're done. But you know your calculator does not recognize base 10 because you don't have to put it in. It does recognize it, but you don't have to put it in. So you would just put in log 17. That's it. And you get 1.230. Okay, last one is same base. Same base. That's how we're ending this. And same base says that this base and this base must match, so you can cancel them out. So I know that 9 is equal to 3 squared. Remember, when we think about bases, we think of powers. And powers means how many times do I have to multiply 3 before I get 9? And that's twice, because 3 times 3 is 9. How many times do I have to multiply 27? 3 to get 27, that's 3 times, which is 3 cubed. So now I take what's on the outside and place it there. And that means that I'm going to be distributing. So once you distribute, you get 2x plus 4 equals 9x minus 3. Make sure you distribute all the way. So minus 2x divided by 7 and x equals 1. If you got a crazy decimal for this, that's because you did not distribute. Alright, so I'm going to give you another secret message. Alright, so you got 3 secret messages. And if you can answer all of these, then you really know me. If you can't answer all of them, that's fine. Just write them down and see if you can get the answers. Alright, so 3 secret messages. Get them to me on a piece of paper. Good luck, everybody. And I hope we get Caesar better. Bye.